All right, homework 3.3, questions 13, 15, and 20. This will be question 13. I'll be leading you in and seeding your brain for probably 3.4 or 3.5 also. All right, the first step here is when you want to do long division, or I always just call it synthetic division, even though technically this is just long division, right? When you want to do long division with the problem, what you want to do is make this the exact thing as this. So, how do I make 2x into 2x squared? X. Say no more. So the x goes into the x column. Okay, this is really important. Okay? Now, x times 2x is 2x squared, right? Okay. X times 2 is 2x, right? And this is, I created this a while ago, probably my third year teaching. So if you don't like it, you don't have to do it, but I'm telling you, I had a young lady yesterday, doesn't like to do things my way, but, you know, because she's learned it her own way, she's like, oh, I can just subtract. Kept messing up. Because that's what we do. We forget that we're subtracting here. Like any long division problem, we're subtracting here. But you forget that you're subtracting. So I like to just go, okay, draw the line and change the sign. Okay? That way you just add them up. Now it's not subtracting, you're just adding. And for me, you know, it keeps it really simple. Draw the line and change the sign. Okay? And this should always cancel out. That's the whole reason we made it the exact same, right? Was to make it cancel out. Okay? Then I have these two together, and I get 8x. And then I bring this down, plus 8. So I ask myself, what times 2x is 8x? What times 2x is 8x?
6.
No, she said it, no. 4, right? 4 times 2 is 8. So 4 times 2, 4 times 2x is 8x. So I'm going to bring that down. There's 8x. 4 times 2 is 8, right? And then, what do I do? Draw the line, change the signs. Right? These cancel, these cancel. Beautiful. That means that this is a factor of this. Okay, that's all that means. Alright? So when I divide it out, I get this. Now, next week, what we're going to be working on is this. Okay? Now, can I factor this? What's 2 times 8? 16. Can you think of two numbers that multiply to be 16 that add to be 10?
8 and 2.
8 and 2. Perfect. Say no more. Alright, so now you've got boom, 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 boom. 2x, 2x, right? This is our 5-step method, right? We know that it's plus plus. And we know that it's 8 and 2. So we've already figured that out in our head. The product and sum. But then we have to, we have to do that star cleanup. Remember, star cleanup says, I got to get rid of this 2. 2 goes into here, right?
2 and 2.
Well, I can't do 2 and 2, right? Because if I do 2 and 2, then, exactly, I have to do 2 and 1. Because I'll be taking out 2 2's. I should have done a GCF here to begin with. Shouldn't I? Yeah. But I did it. I skipped it. But what happens here is, I've got x plus 4, right? And I've got 2x plus 2, right? And look at this. This cancels with that. Yeah? Oh my goodness. Ba-bam. X plus 4. And that's the same thing as what we just did there. This is what we'll do next week. Okay? But I just want to make sure you know how to do this. Okay? Because it doesn't always come out nice. Sometimes you have what we call remainders. Okay? Is that pretty clear? And of course, next week, we get to learn that, oh, the bottom can't be 0. Right? You can't have 0 in the bottom. What's a number divided by 0? It's undefined. You can't do it. Right? So, 2x plus 2 cannot equal 0. So this isn't a true answer. This is baby step answers. Right? The true answer is, well, I moved the 2 over. Minus 2 minus 2. 2x equals minus 2. Divide by 2. So I get x equals negative 1, right? Or cannot equal negative 1. So I say here, whereas, I use that symbol we haven't seen since last year, whereas x cannot equal negative 1. And this is what we call an asymptote. And this is what we'll be learning next week. It's about asymptotes. Okay? This is not today's assignment. This is. It's all you'll be doing and all you'll be doing tomorrow. Okay? Good?